Okay. So you will see a folder called Prelab Discussions. In Prelab Discussions, you do have recorded video about purpose for each experiment and what to expect, what type of data you are recording from the experiment that you are watching on the video, the video for the experiment. So as soon as I submit the links, you will get the notification. I'm going to do that very soon. So other than the pre-lab discussion, do you have any questions about the experiments that you have read so far? Any questions? Questions or no questions at this point? No questions? No? Any questions from group 1? Do you know how to approach what to do for the group 1 and 2? Known sample, what are you looking for? I hope you had a... Can you hear me? Could you please tell me what you are, if you have any questions for me?
Professor, I have a question. I mean, for the experiment, like when you say to read them, you read them in the ebook?
Yes, you read the experiment in the ebook.
Okay.
You read the experiment in the ebook, then you watch the video. There are 2 sets of video, and you must watch both of them. One is the pre-lab discussion for the experiment, and the second one is the video for the experiment.
Where I'm gonna find a video on the ebook also, or you're gonna post it in D12?
They are already in D12. The video is already in D12.
Oh. So you go to content and then you can see the video for experiment 1?
Experiment 1, you go to the course content, and I can share with you now for you to see where to locate it, but I was hoping that you already have watched some of these experiments, some of the videos already. So let me, I just want to do one video so you can see what I mean by that, and I will update the rest later. Okay, so let me just add that pre-lab discussions because you need to see how it looks like. Okay, so you are going to go to homepage. You look for the coursework and experiments, and you look for week 1, which is the qualitative analysis group 1 and 2 known sample. That's one folder that you will be looking for, and the other folder is called pre-lab discussion videos. So for pre-lab discussion video, where it says experiment 1, week 1 pre-lab discussion, you click on that, it will give you, it would give you the general understanding of the experiment. I'm going to stay quiet. I don't know if you can hear the video or not. Tell me if you cannot hear. Okay. Can you see the video or no?
Yes, I can see it, but I don't hear anything.
Class, can you see the video?
Yeah.
Yes, okay, good. So I'm going to trim the video and get the first like 5-6 minutes removed from it because it doesn't pertain to you. But starting from this table, which is the chart for group 1 and 2. Okay. Okay, I'm gonna let you watch this on your own time, but the way that it's explained based on using the chart when you are working with group 1 and 2, this is the flow chart. And when for the report, when it says to draw the flow chart, instructions to draw flow chart is given to you. So you would copy, or the flow chart should look like the content at least should be exact the same as this flow chart, but you are going to create the flow chart yourself. In this group, or the ions present, they are lead, silver, copper, and bismuth. To be able to read the flow chart is one of the competencies for this experiment. So when you read this flow chart, what it means, at the beginning, you have all these 4 ions because it's a known sample. Then when you add HCl, 2 of these ions would change to the precipitate. How do we know they change to precipitate? Because the solid, or the symbol S stands for solid, and solid means that these 2 have precipitated. But the other 2, copper chloride and bismuth chloride, do not precipitate because they are soluble in water. So you are able to separate these 2, and between. I'm sorry?
Oh, nothing.
Okay. So these 2 ions are changing to precipitate. In a test tube, you are going to centrifuge the test tube. The centrifuge step, it doesn't show on the flow chart. And you don't have to put that in your procedure, part either, or the flow chart that you are drawing. But it's understood that in between, you have to separate it. So you are changing all of the 4 ions that you have into 2 pieces or 2 parts. The aqueous solution is going to contain copper and bismuth, but the precipitate that forms, the solid that forms, is silver and lead. And going back to purpose for this experiment, you want to separate each of these ions and identify it based on the evidences of the reaction. So you might see either precipitate, you might see color change. You have to look for evidence for presence or absence of these ions. For the known sample, we know we have all 4 of them. For the unknown, you could have only 1, only 2, or only 3, or all 4 of them. So for the unknown, you have to repeat the same procedure unless you get to a point that there is really no need to continue on one part of the experiment. And that's a question also in one of the pre-lab, post-lab questions. So when you separate, going back to like step 1B, what happens in 1B? In 1B, the precipitate that you have, the solid that you have, is a mixture of silver and lead. For you, the next logical step would be to separate these two. So when you are separating these two, first you're adding hot water. How do you know you have to add hot water? The procedure is adding hot water in the video, but that is coming from procedure from the ebook. So I want you to read the ebook and follow the procedure step by step as you're watching the video. This way you understand what's the next step, what's the next logical step, and what needs to be done. So when you add hot water, what happens? Can someone tell me what happens when you add hot water? If you look at the chart, you have the answer, but I want someone to read the chart and tell me what happens when you add hot water.
It separates the molecules.
Which one? And how is going to be separated? Very good, but how is going to be separated? If you look
Not
at the
sure.
symbols for the chemicals that you have in the boxes, you should be able to answer this question, even if you didn't read the experiment before. And if you read it, it's even better.
Yeah, like I was watching the video, but I haven't read it yet.
Oh, you need to read the experiment, but if you look at this flow chart, it says when you add hot water, you see what happens. AgCl still is S. That means it still is in the precipitate or solid form, but PbCl2 has dissolved because you see that AQ symbol there. So AQ means that it's in aqueous solution or has dissolved, but S means that is in the solid form. So when you add hot water, you are going to separate silver from lead ions. Now you have a liquid portion and you have a solid portion. You again centrifuge and separate. What's the purpose of centrifuge? Centrifuge is going to make the solid to settle down completely. So when you are pouring the liquid, the solid doesn't leave at the same time. So you are going to have now a solid and the liquid. The liquid contains the lead, solid AgCl. How would you confirm you have lead? In order to confirm you have lead, you're adding the potassium chromate. When you add potassium chromate, you would get a precipitate. This precipitate is going to be yellow color, very obvious, texture of the precipitate. And at that point, you are going to confirm that yes, you do have lead. For the unknown sample, it's going to be the same. First, you are adding HCl, then you keep the solid in test tube, the liquid to transfer to another test tube. When you have the solid, you add hot water. If there is any lead in your unknown, it will go to the aqueous solution form. And if there is AgCl, it would stay in the precipitate form, in the solid form. Now to the solution, after your centrifuge, when you add potassium chromate, if you see the yellow precipitate, how do you know precipitate forms? When you watch the video, you might look for the solution that is not clear. It's like particles moving in there. It's cloudy. A cloudy mixture, that means a precipitate has formed. Sometimes it settles down, it separates. Other times it stays in the solution floating. But when you see a cloudy solution, that means you have a precipitate. If you see a yellow color precipitate, this is for the unknown, that means you have lead in that unknown. Lead ion was present. So for the known sample, all of them are present, but you still have to watch and you have to write the steps. In the boxes, you have to write down what is happening. So in the flow chart, those empty spaces are for you to write evidence for the reaction. If something dissolves, if the color change, if new color appears, if a precipitate forms, something in that nature. And that goes into those empty boxes in the flow chart. How would you find out you have AgCl or not? Can you tell me based on the chart, what would you do to confirm that you have AgCl or Ag ion, silver ion?
You
What
would
is
add
happening
ammonia.
when you have the solid? Yes,
You would,
Lauren, go ahead.
yeah, you would add ammonia.
You would add ammonia. When you
Mhm.
add ammonia, then the silver ion, I'm sorry, silver chloride, is solid silver chloride is going to dissolve in ammonia and it would go to aqueous solution. That's at that point is not still confirmed, but that's the first step. And the second step, you're adding nitric acid. When you add nitric acid to the solution that you would expect to have silver ion, it would go back to solid again. So if what you have left in the test tube, it behaves with this pattern, then you confirm that yes, there is a silver ion in this mixture. As I said, for the known sample, you have all 4 of them, but you have to practice, because if you don't practice with the known sample, you will not be able to identify your unknown. Now, you had a test tube that you would expect to have a copper ion and the bismuth ion. How do you separate copper from bismuth? First of all, you want to make sure that there is no leftover of lead. So you add the sulfuric acid. When you add sulfuric acid, it would remove anything that was left from lead or silver. So when you add sulfuric acid, you see nothing changes. You have bismuth and copper in aqueous solution, and that's how they stay. But after you clear and remove any leftover of lead, like if you didn't read the procedure, this part like 2A would not make sense to you. Say, why they're adding H2SO4 and nothing happened? So you have to read the procedure first. Then you are going to see the copper ion and still mix with the bismuth ion. But when you add ammonia to this solution, only one of them precipitates. And that's the point of discrimination. Like you have to get one point of difference. So one has to behave differently than the other one. One stays in the solution, the other one goes to solid. Then you centrifuge, you separate. Now, if you have bismuth, when you add ammonia, you would get a precipitate. When you get the precipitate, then to that you're adding sodium hydroxide and tin chloride, and you will see like a black precipitate. Sometimes you will see like a gray color, which is a mixture of black and white. Sometimes you would just see a couple dots of black. That is still confirmation that you do have bismuth. Because if you didn't have bismuth, after you add ammonia, you would not get any precipitate. So when you get the precipitate and those 2 steps, don't look for like jet black color. Even though it says look for the black color, black precipitate, there would be like only a couple spots for the black precipitate for the bismuth. And how would you confirm? So that is like confirm that you have bismuth. How do you confirm for copper? Presence of copper, you add the acetic acid first, and then after you add the acetic acid, then you are going to add the okay. Then you are going to add the reagent just to make sure that you do have copper. So look at the pattern. You are separating. You have mixture of 4. First, you separate to 2 and 2. Then you separate to 1 and 1 for the separation. Because if you don't separate, you're not going to be able to identify. So for experiment week 1 and week 2, you are working basically off this chart. But there are 4 videos that you are going to watch for that. And the videos are not too long. During the pre-lab, sometimes I wait for students to respond, so it takes longer. But the experiment actually is just, I do the experiment fast. So since I do the experiment fast, I'm by myself, nobody asks questions. So I'm not slowed down. I don't think, I already know what I need to do. So the experiment is kind of fast. The only and the best way to understand what's going on in the experiment is to read the experiment from the ebook first, and then watch the video, record your data, write on a piece of paper, because if you were in the lab, you were having a lab notebook to record the numbers, to record the your observation. So there should be no difference. You're not watching movie. This is a video based on the experiment. You're watching just to collect the data. And when you have your data, if you already have your flowchart and you record the numbers and the evidences directly into your flowchart, that's even better. If you can't manage all that together, like if you don't have, you know, 2 devices or 2 screens, then have the flowchart, hand draw it on a piece of paper in a spiral or composition book, record your observation, and then go back to write the report. The more observation and the more detailed observation you write down while you're watching the video, the easier is going to be for you when you are writing your report or answering the questions for the pre-lab and post-lab. Any questions?
So at the bottom of these little boxes, what do we put here in that blank space at the bottom? Like, let's just
At
say
the bottom, the empty spaces, you write down your observation. Like right here, basically you just say a solution, a mixture of all. You just put the color of the solution, whatever it is. After you add HCl, and when you separate it, then you have here, this is the solution, color of the solution. Here you have a solid. So you just say a white solid has formed. After you add hot water and you separate it, HCl, if there is a precipitate present, you just say solid compound. Here is like a solution. Again, a clear solution. Here you get a yellow color solution. Basically, you are using this space for your observation, whatever you see in the experiment. Good question. Any other questions you might have? Any questions or concerns you might have?
So you'd have to include like the steps in between like when you
Let me
add
increase the
ammonia.
volume. I think I lowered the volume on purpose here. I'm sorry, one more time.
So in between the boxes, the arrows, you have to put like molecules or like what you use to separate it, like the hot water or the ammonia.
Yes, the reagents. The reagent goes into the arrow. On the arrow, you write what reagent you are adding. Yes.
Okay, thank you.
You're welcome. Any other questions you might have? Because this is the meeting for both known and unknown group 1 and 2. And you're going to watch, of course, the videos are available there, but the best time for you to ask your question is like this time of the lab when we are meeting. And these are due for all 4 of them, or 6 assignments. They're all due on the 25th, 11 a.m. Please do not wait until the last day, because then it's just a lot. Also, pay attention to the announcement. In the announcement, I have a template for mini lab report. I have sample mini lab reports. I have instructions how to draw the flowchart. So pay attention to the announcements as well. You just go down the announcement, because I didn't put all in one announcement. You just have to go down to the next announcement. That's one other reason that I don't want to post the meeting schedule or the link for Zoom, because it takes a lot of space, and then all the announcements go down. So if you go communication Zoom, the meeting shows up there. Anyway, okay, any questions you might have? Can I help you with any questions? Any concerns?
I have a question.
Sure.
So for the pre-lab, I was looking and it said hydrogen chloride is added to a solution containing both lead and silver. You know, how many different solids? I thought at first it was 2 separate solids that they would separate, But now looking at the flow chart, I'm kind of confused, and I think it's just one, and that they separated from the BI. I'm sorry, I can't.
But your answer, okay, but your answer that both of them is going to be together, it is correct, because at that point when you add HCl, there's no way to separate them. So if you put both of them together, is fine.
So it would just be one solid containing lead and silver, correct? And they're just separated from the other two known to
Yes. It's not one solid, actually.
element.
It's a mixture of two solids. Silver chloride and lead chloride. They are different from each other, but they are mixed together because both of them precipitated at the same time. So it gets like mixed together, like salt and pepper. And then when you add water, salt dissolves, but pepper doesn't dissolve. So in that case, lead chloride acts like a salt, and then silver chloride acts like pepper.
Okay, but would it be two solids or one? Because you said it's two solids in one mixture.
Okay, what are the ions first that you added there? You had to begin with before adding HCl.
It's lead 2+, and then silver plus 1 ion.
Okay, then it's two solids mixed together.
Okay, that's what I put, but then I got confused looking at the flow chart. Thank you.
You're welcome. So when you look at this flow chart here, you have like 4 ions together. 2 of them would mix together. So you have the lead chloride and solid, and silver chloride, both of them solids. Yeah, when you look at the flow chart, it's supposed to clear stuff more rather than confusing you, but I'm glad that you asked the question now. Is there any other questions you might have? Any questions? Your questions, please give me your questions so I can answer them. Now is a good time to ask questions. No questions?
Actually, I have a question.
Yes.
I'm looking at the conclusion from the sample report, and I noticed that the conclusion is like really long, like about a page worth of like words.
One
So
paragraph is good. In the conclusion, please make sure to include like clearly which ions are, especially for unknown, which ions are present, which ions are absent, because it's going to make it easier and faster for me to grade. That's something that I was going to ask. If you have one paragraph conclusion, it's fine. You don't have to repeat every step of the procedure. So the sample that I posted, is a good sample, but it's not perfect. And you don't have to do that much for the conclusion. One paragraph is good enough.
So we just list the ions. Like, I'm a little confused.
Okay. Let me put it this way. When you are writing the conclusion, you want to say what test was done that confirmed you had silver ion, which test you performed, and what was the evidence that showed that you have lead ion. Same thing for copper and bismuth. So you basically rewrite everything that you have on the table, but in a word and a paragraph format. You would say, the purpose of this experiment was to identify the ions present in this mixture, okay, of the known group 1 and 2. And in order to identify, you did the following. You could say formation, if you want to like summarize it short, you could say formation of the lead chromate solid, yellow color lead chromate solid indicated presence of lead ion. Okay, and then by adding the HCl, I don't want you to repeat the whole procedure. That's what I'm saying. Like you can say by dissolving the AgCl in ammonia, since the precipitate of the AgCl dissolved in ammonia, and by adding nitric acid, white precipitate formed again, which indicated presence of silver ion. So that's what I'm interested only. What evidences showed that you had lead? What showed that you had Ag? What showed that you had Bi? And what evidences showed that you have Cu2 plus? So if you add them all together, that's like 5 sentences, and that is like 1 paragraph. And like in 1 sentence also, if you just say ions presence, ions absent, also add that.
Okay, that helps. Thank you.
Perfect, you're welcome. Okay. Questions? Questions or no questions?
I have one more question.
Sure.
Okay, so I was looking again at the pre-lab and it's saying copper is in 1 test tube and silver is in another. It added, add HCl. And the only step I see would be the first one for that. But
Perfect.
I don't know.
If you have copper,
like...
if you have a copper and silver, there is either copper or silver. When you add HCl, one would precipitate, one doesn't precipitate. And that's how you distinguish between the two. The answers doesn't have to be like too long.
Okay, thank you very much.
It's just purpose of understanding. The pre-lab is trying to help you or confirm that you have read, you know how to read the chart, you know how to read the procedure, and then you can predict what's going to happen if you have one or the other in a test tube. You add HCl, what do you expect to happen?
Okay, I think I'm just reading too hard into it, maybe.
This is okay. If it's better to start that way than not care. You're doing good.
Thank you.
You're welcome. Any other questions you might have? Any other questions you might have? So what you do, you go to assignment folder, or when you are actually looking for the assignments, like for this assignment, when you open the assignment, it tells you to, no, it shows me something else. It shows me submission. Okay, here it says download the attached experiment 1 week 1 pre-lab questions, complete all the answers, save, and submit to this assignment folder. So you click on this, you click on that file, which is a Word document, you open it, and you answer those questions. Do you see now the Word document, or you don't see the Word document? I
see the Word document.
Okay, so what you do here, you just answer the questions. Like it says HCl is added to the solution containing this to how many different solids are formed? What are the formula for those solids? So someone said that these are like a PB CO2. So you are going to write that and format it, because there should be no space here. And then that should be superscript, like, I'm sorry, subscript CO2. So that is a precipitate. So you are going to, that's why I use the Word document. Okay, because I want to make sure that it's easier for you to format. Format it properly, save it, and then submit. So for assignments, you don't need the pictures.
Oh, okay. So to do the assignment, you have to watch the video and then with the experiment in ebook, that's when you will answer the question, right?
Yes.
Okay, I understand. So every assignment, you click on them and then you have the work document and you tap the answer and then you save it, you submit.
Save and submit, yes.
Okay, I understand now. Thank you so much.
You're welcome. Any other questions you might have?
Yes, Professor. My question is about points taking off when we're writing these experiments, because I guess my concern is just that I can watch the video and I can write the information and the data and record the data, but I guess what if I make a mistake when I'm writing my report? I mean, you're not going to be there to answer my question, or I have to wait until the next office hours to get my question.
The answer to all of the questions asked on the pre-lab and post-lab, they are in the ebook. So you read the experiment, you can answer the question. So word by word, you read the ebook, you can find the answers there. So also watch the pre-lab discussion. I answer a lot of questions during pre-lab discussions. So the answers should be found there. The experiment, when you watch the video, is you're recording what you see, and you're not the only one watching that video. Everyone in class is watching the same video. So if there is a precipitate forming, yes, there is a precipitate forming, and then you would say, you know, precipitate is forming. If there's no precipitate, then there is no precipitate. So it's basically, for the first 4 weeks, is basically presence or absence of ions. In order to say the ion is present, you have to look and wait and see evidence that is expected from that ion to show, in order for you to say the ion is present. If you don't see that evidence, you would say there is no, that ion is missing. So if you watch the video, so I really don't get the concern that you have. If you answer the question wrong, that means you didn't answer the question right. So you didn't read the experiment carefully, or you didn't watch the video carefully. But I guarantee, if you watch the video carefully and you read the experiment carefully, you should be able to answer the questions. And since it has not happened yet, it's very hard to say hypothetical answers based on that. If you tell me if I went like too far, or I didn't answer your question, ask your question again, please. So if you're worried about where to find the answers to questions, my answer would be, you find those answers to the questions in the ebook.
Okay, I wasn't worried about the answers. I was worried about the format, maybe more specifically, specific words, because I know some professors like their papers or its answers to be answered in complete sentence. Some just want the answers. It's more of the format in which you want your answers to be, the responses to be written. Okay.
Now, for the format, so I'm glad you clarified your question. The format, you look at the question. For example, this first question is asking how many different solids are formed. Then you just say 2 solids are formed, if the answer is 2. If 5 solids are formed, you just say 5. And says, what is or are the formula of these solid compounds? Then you would just write the formula for it. And in question 2, it says AgCl is in one test tube, PbCl2 is another test tube, hot water is added to both test tubes. Okay, describe what will occur in each of the test tubes. Now, what's going to happen if you add hot water to test tube that contains PbCl2? We just talked about this. And when you read the experiment, you will see that if you add hot water, or when you look at the flow chart, you see that PbCl2 will dissolve. And that's what is asking you. All you have to say, PbCl2 will dissolve. So this one requires a sentence. The top one, it required only number and formula. So it depends on question. I'm not asking for paragraph for each question, if that's your answer. And then for the mini lab report, I gave a sample in the announcement. Read and look at the sample before you write your own mini lab report. It's going to help you. Did they answer your question, Rose? Or concern?
It answered my concern, but I guess I'm trying to make sure that I don't get any points taken off my lab reports.
Well, if it's right, there would be no points taken off. And even if it's since it's the first time that you are writing, let's say, a report or something, since this is not the only grade that you will get in the semester, and this is not the only report that you write in the semester, then it will, it's a learning process. So you would get the feedback and you would do better on the next one. So we are, here to learn new techniques, new things, as well as just solid information. So don't worry about if you just miss like 1 point. It's not gonna make you fail the course or lower a letter grade. 1 point or 2 point out of that many points is not gonna affect your grade like greatly, too much. So let's just you do your part. If you follow the instructions, you will do fine. Don't worry about it too much. You know who is going to be in trouble? If someone doesn't attend the meetings, someone doesn't read the ebook, someone answers the questions or look for the answer online, just search up the answers without reading the question carefully, or doesn't spend enough time. I hope I don't have that someone in my class this semester, at least. Should be fine. Don't worry too much. Okay. Any other questions? There's no pressure for Rose to ask questions. Someone else.
I have another question.
Tell me, what's your question?
Well, so it says, what is the formula of the solid? Do you just want us to simply write Ag or Ag plus Cl minus equals...
No, it says formula for solid. The formula for solid is going to be HCl solid.
Okay. And when it says new chemical formula, that's when I do the long one, or is that still
no,
the
it
very
says,
simple?
No, when it says chemical reactions, then you write the long one.
Oh, okay. So chemical reaction is the long one, and the chemical formula is a very simple Ag.
No, that's for the ion. Ag plus, that's the formula for ion. So if it says formula for a compound or formula for precipitate, you just answer that formula for the precipitate. But if it says reaction for forming of that, a chemical reaction, if you want to show the chemical reaction, then would be Ag plus Cl minus, that gives AgCl. So the term is different, right? You have the Ag plus ion, that's just the formula for the ion. You have Cl minus is a chloride ion. AgCl is the formula for the solid that is forming. So if the question is not asking for the equation, you don't have to write equation. Equation is like a reactant and products separated by arrow sign. But if it's just a formula for precipitate, it's just the product.
Okay, so Ag plus is the ion. The long one is for the chemical reaction, and then the AgCl would be the solid, for example.
Exactly.
Okay,
yes.
Thank you very much.
You're welcome. Okay, any other questions you might have? No questions?
So 100% we would meet on Thursdays to discuss whatever labs we're working on, and then we just watch the videos for the Tuesday and the Friday, right?
Yes.
Okay.
It's not every Friday, it's every other Friday. For Tuesday and the every other Friday, you watch is a set of 2 videos. One is the experiment, and the other one is the pre-lab discussion for that experiment.
Correct.
Yes. And when you come on Thursday, like today, we talked about the known and unknown. Just be ready to ask questions about the experiment studies for that week. Everything is set for that week. So for next week, it's going to be known and unknown for group 3 ions. And then you are moving to experiment 2, which is kinetics. So since you have to watch these videos, if you watch it earlier, it will answer a lot of questions. It also helps you to come up with questions that you might have. Just like Lauren is asking, questions. Clearly, she has either submitted already the assignment or she has completed the assignment by asking these questions. And then I had a few other questions, very good questions yesterday during our office hours and today. So I just want to make sure that you are, using the time and schedule. Your schedule is like spread out, is not condensed to day before due date for these assignments. Okay, I'm going to stop recording because, or at least pause it, because I don't want these videos to be too